We now consider a couple of follow-up problems to the braking problem. First off, we compute the probability of a type 2 error if the braking distance has decreased to 155 feet. And lastly, we determine the number of tests required if it's required that the probability of committing a type 2 error with mu equal to 155 is equal to only 1%. To get started on this, we'll take a look back at the formula for beta under a new null hypothesis. In this case, we have a left tail test, and so the formula for beta is given on the screen: 1 minus phi of negative z alpha plus mu naught minus mu prime over sigma over square root of n. In our problem, we would have 1 minus phi of minus z alpha. That'll be the negative 1.64485 figure. Recall that z alpha is always positive, and so negative z alpha will be negative, plus mu naught, that was the old average of 159, minus mu prime, that is our hypothesized new mean of 155, divided by sigma over the square root of n. We recall that we figured out that the standard deviation was 19.9405. And that, of course, is the sample standard deviation, not the population standard deviation, but that is our best guess, divided by the square root of n, which is the square root of 45. Okay, so we do use Excel to do the arithmetic here. So the thing in the parentheses will be equal to the z value, be 11, plus 159 minus 155 divided by the square root of the standard deviation over the square root of 45. So we get negative 0.2291, negative 0.29921, pardon me. So that's the area to the right of negative 0.29921, and so we can find that with Excel. So beta will be equal to 1 minus norm s dist of the number we just got. Using a TI calculator, you can find the area between negative 0.29921 and plus infinity, or 10 to the 99. And so our beta works out to be 0.61761. 0.61761. Okay, so that is the first extension. The second extension is to determine the number of tests that are required if we want to have beta of 155 equal to 0.01. To do this, we have the formula for the number of samples that are required to obtain that level of accuracy. So we have n equals sigma times z alpha plus z beta over mu naught minus mu prime, whole thing squared. And this formula applies if I have a left tail test or a right tail test. So n would be equal to 19.9405 times, well, we have the negative 1.64485. So that's positive. Z alpha is positive. Plus the same number for beta for 0.01. So let's get that number real quick. So norm s in of 0.99, so that 1% of the area lies to the right, is 2.32635. Okay, divided by the difference of the two means, 159 minus 155 whole thing squared. And so doing the arithmetic, let me get the other number here for simplicity's sake. So there we go. And the standard deviation is here. So doing the computation, we have this will be equal to the standard deviation times the sum of those two percentiles, two z-values, divided by 159 minus 155 whole thing squared. So it takes a lot of tests, about 392. So that's how much testing will have to be done, we project, in order to obtain a beta as required, that beta of 155 is equal to 0.01.